Okay, so it says that Sal has a pentagon, ABCDE, it shows it there. He translates the pentagon 2 units to the left, then reflects the resulting image over the y-axis. So composition of transformations, you have to do them in the order it states. So the first thing is translate it 2 units to the left. So you're going to take each point and just move it over 2 units to the left. Do this shape. Okay, then he reflects the resulting image over the y-axis to create pentagon LMNOP. So identify your y-axis, and then in reflecting the points, you just make them the same distance on the other side. So like right here is one away. This is 1, 2, 3, 4. 1, 2, 3, 4. You can also use the coordinates to help you. This is at +2, so this one will be at -2. This is at 7, so we put it over at -7. 8 and oh wait, this is at 6, so this will be at -6. And then connect your dots. Okay, and then this is your official answer. This is just the interim. We needed it to get to this answer, but it's not part of the answer, so I would go through and just delete those points so they aren't part of the answer, and don't throw off the answer. Okay, next. For this one here, it says a diagram is shown. Core uses the diagram to analyze the given statement. When a transversal intersects parallel lines that are shown, 2 angles are supplementary if and only if they're adjacent angles. Adjacent angles are angles right next to each other, and in this picture, all the adjacent angles would be supplementary. However, it's not the only situation where angles are supplementary. Over here it says select one angle from each column to show a pair of angles that represents a counterexample. So a counterexample to this would be, okay, this angle and this angle are supplementary and they're not adjacent. So counterexample, star plus star equals 180, even though they are not adjacent. Okay, and then over here you would have to like click the ones, let's see, FGH, and here GMP, PMG. Okay. And obviously that's not the only correct answer, it's just one, and that's what it says. Select one. Okay, next. Okay. Next is a construction problem. Like I said, you won't have to like break out a compass and make a construction, but you will have to answer questions about them. This is one thing that my students said they wish they had paid more attention to. They thought constructions was just like a fun drawing activity, but then it ended up being pretty prominent on the EOC. So here it shows the original angle. It says that using a compass and using the same like opening, they make this mark and this mark. And then from there, using the same compass width from step 1, they put the compass on C and make this mark, and then put the compass on B and make this mark, so it crosses. And then the next step would be to draw this line and make an angle bisector. Over here, it wants us to answer questions. It says select the phrase to create the true statement. Constructing segment AD, which is what we did right here, will create 2 congruent angles. Yes, it's an angle bisector, so like this angle will be the same as this over here. And so you'd click the drop down, and it wants to know what angles are congruent. The triangle BAD is congruent to triangle DAC. Because AD is an angle bisector. And then part B, it says select all the lengths that are equivalent to AB. So this segment right here. Well, using the compass, we made this mark over here, so that would be the same length. Then also it said using the same compass width from step 1, they made these marks. And so these would be the same, and so would all of these. So AC would be the same as AB. Then AD, no, it looks longer. BC, we don't know. BD, yes, it's the same length because we use the same compass width, and same with CD. Okay, and the next one, it says a figure is composed of a right cone and right cylinder with dimensions in feet is shown. What is the exact surface area in square feet of the figure? Okay, so exact surface area, the way that's most exact is in terms of pi, because there's no rounding involved.
Are we supposed to know that? Test?
Yeah, I would say so. I don't know.
It won't tell you in terms of pi.
I don't. Sometimes it will say in terms of pi. Just try your best. Just try your best.
We use rigged. We use.
I know it is rigged. Yeah. Somebody got a perfect score last year though. So it's possible. What's that?
We use 3.14.
It says exact. So I'd say in terms of pi would be best. But I don't remember whether it accepts decimal too. Anyways. So we need to find the surface area of this whole thing. So we're gonna find the surface area of the cone and also the surface area of the cylinder part. And so surface area of a cone using the reference sheet. Surface area equals area of the base plus pi RL. Surface area equals area of the base plus pi RL. And I know some of you are already 2 steps ahead of me. R is the radius and L is slant height. So slant height right here would be 2.5. And then for the cylinder, let's see, cylinder surface area is 2 times area of the base plus perimeter times height. Surface area equals 2 times area of the base plus perimeter times the height. Okay, so for the cone portion, the base wouldn't be included because it's on the inside. It's not part of like the surface area. So we actually cross that out and just find the lateral area. So lateral is just like all the way around, not including the base. So surface area equals pi RL. And so surface area equals pi. The radius, if this is 1.5, the radius of the cone, 1.5. And slant height is 2.5. So surface area equals 1.5 times 2.5 is 3.75 pi. And that would be like feet squared. That's the surface area of that part. Then for the cylinder portion, there's only one base that's exposed and the other one is on the inside. So for this, you're only going to use the area of one base. And the area of a base would be area of a circle, pi r squared. Perimeter would be like all the way around like this, would be the circumference of that circle. So pi times diameter for circumference times the height of the cylinder. Then plugging in numbers, the radius 1.5 squared. The diameter, the radius is 1.5, so diameter is 3, and the height is 3. So we got 1.5 squared would be 2.25 pi plus 9 pi. And then adding those together, we get 11.25 pi feet squared. And then from here, add those two, so this is the surface area of the cylinder part, and then add those two values together to get the total surface area. Oops, okay. So 3.75 pi plus 11.25 pi equals 15 pi. So that would be your total surface area, feet squared. Then when you're done with that, flip it to the next page, the back. Okay, so on the back, we just are going to do these 3 problems, and that's all we're doing for today. So the first one says, a scientist discovers a spherical object in the solar system with a mass of this and a volume of this. He uses the table shown to classify the planet based on its density. So if the density is between 0.3 and 2.1, it's a gassy planet. If it's between 3.6 and 13.4, it's a rocky planet. Select a word to classify it, and then classify it, and put the density here, rounded to the nearest tenth. Also something in this problem, I think it's like a typo or an error. Here it says cubic centimeters, and here it says cubic inches. We're just going to pretend it's all 1 unit, so that seems overly complicated. So for density equals mass over volume, and you have to have that equation memorized. It says the mass of this planet is 1.1 times 10 to the 25th power, and then the volume is 2.9 times 10 to the 24th power. Then from here, you want to solve this. In this calculator, it might be a little bit tricky. You could do it. You could also use the EOC calculator to put this all in, or you could just simplify these x like this over here. So 10 to the 25 over 10 to the 24th power, that would be like 10 times 10 times 10 times itself 25 times over 10 times itself 24 times. So like all 24 tens would cancel out, and you'd just be left with 1 10 on the top. So we get 1.1 times 10 over 2.9. 1.1 times 10 would be 11 over 2.9 equals 3.793. It says to round to the nearest tenth, so that'll be 3.8 grams per centimeter or cubic inch or whatever, centimeter cubed. So that is our density here, and then we see which category it falls in. 3.8 would be between 3.6 and 13.4, so it is a rocky planet. Okay, next. The next proof is more of like a level 3 proof. It's pretty simplistic. It says, given that F is parallel to H, it wants you to prove that 3 is congruent to 6. So the first one, it says corresponding angles of 2 parallel lines cut a transversal are congruent. So you'd click the drop down and you just choose the ones that are corresponding angles. The ones in the answer choices that are corresponding is angle 2 is congruent to angle 6. So 2 is congruent to angle 6. Then it says that vertical angles are congruent, so you just want to choose the vertical angles in the answer choices, and it would be angle 2 is congruent to angle 3. Then it says that 3 is congruent to 6. Those are alternate interior angles. However, alternate interior angles isn't in the answer choice. So what they want you to choose is something else. Let's see. So if 2 equals 6 and 2 equals 3, then 3 must be congruent to 6, and that's transitive property. Okay, the next one, it says a right square pyramid and a sphere are made of marble. The dimensions of each figure in feet are shown. The density of marble is 160 pounds per cubic foot. So density equals 160. Density equals mass over volume. It says, what is the difference in pounds between the weight of the sphere and the weight of the pyramid? So difference in pounds, so the difference in mass. The way to figure this out, we know the density. We don't know the volume. We're going to have to solve for the volume, and then we can use this equation to find mass. So we're going to need to first find the volume of the pyramid, and then also find the volume of the sphere. So volume of a pyramid, volume equals 1/3, area of the base times height, and then volume of a sphere, 4/3 pi r cubed. Okay, so it says this is a square pyramid, so if this is 1.5, then this is 1.5. And we can plug these numbers in. Area of the base is a square, so it's just 1.5 times 1.5, and then the height of the pyramid is 2. You multiply this all out, and the volume comes out to 1.5 feet cubed. Then for the sphere, volume equals 4/3 pi. The radius of the sphere is just 1 cubed. And then multiply all that out, and it comes out to 4.1888790. And then that would just be like feet cubed. Okay, so now we have the volume of each, we know the density of each, and we can use that to find mass. So density equals mass over volume. The density is 160, the mass we're trying to find, and the volume is 1.5. So same over here, 160 equals mass over 4.188790. Trying not to round at this point, just so my number's not off. And then from here, multiply both sides by 1.5. The mass equals 240 pounds. And then over here, multiply this by 4.18888. 4.1888. Mass equals 670.2064. Okay, and then from here, subtract. It wants to know the difference between the masses, so we subtract them. And it comes out to 430.2064. It says round your answer to the nearest hundredth, so 430.21. And then you might be thinking, like, what if I didn't write out all those numbers, or what if I used 3.14 because it never really said what to use? So it'll accept like a range of numbers from like 430.1 to 430.5 or something like that. So as long as your number falls in that range, you will be good. Yes.
Should we always just use pi?
I would use pi to be most accurate, unless it says otherwise. I know, and Alex, they always said 3.14, so. Educate. Okay. Ow, I just like cramped my neck. Okay, so your to-do list now is to do homework number 6 on Schoology, and turn in your packet if you haven't already to do homework number 6 on Schoology. Turn in packet from last year.
I'll think about it. Okay, is it here?
Yes, you may.
Sam.
Shut up!
Oh, I can't. Well, alright.
From what?
Sam, please, Sam.
Chow, you look like a grandma. Oh yeah? Yep.
Bro, Sam.
At least I got it.
Sam, you're early.